I'll first now go through a little structure how I'm planning to take the sessions, and then we'll get started with the today's topic. So basically, data structure, if you see right, data structure has two parts. Basically, it's a unidimensional and multidimensional. Basically, data structure, if I have to divide broadly, I can divide it into the two parts, unidimensional and the multidimensional. So unidimensional will contains anything which has one dimensional data structure. For example, arrays, linked list, stack, and the queue. And the multidimensional data structure I'll talk about will be around trees, graph, and then maybe priority queues or heap, map, something like this. So basically, we can divide the whole data structure into the two parts, unidimensional and the multidimensional. We'll be starting with the unidimensional data structures. I say unidirectional data structure because in these data structures, you always move in a single direction. There's only one way that you move, right? In the multidimensional, there's no single path. There are multiple paths through which you can traverse. So that I call it the multidimensional data structure, like tree, graph, priority queue, heap, map. I understand that you guys will be already little comfortable with the unidimensional data structure, but trust me, unidimensional data structures involves more tricky questions than multidimensional data structures. Multidimensional data structures needs a little more effort to understand it at the first go, but once you know the concepts of the multidimensional data structure, it's much simpler. I must tell you, you might be a little apprehensive about the graphs as of now, but I feel graph is one of the most easiest data structure if you have to count all of them, because if your concepts are right about the graph, you can easily solve the problem. There are not many combination of the problems that can be formed in the graph, but the array, which is supposed to be most easiest data structure, it is one of the most trickiest part of the data structure. Anybody can ask you any tricky questions which will not be logical, and you'll be struggling to solve that. So the array appears to be one of the simplest data structure, but it is not the fact. It's the most trickiest data structure that you can face in any data structure algorithm questions. So this will be about the data structures, and once we cover the data structure, we'll be talking about the algorithms. In the algorithm, we can start with the string algorithms, right? And then we talk about many things like divide and conquer, backtracking, test dynamic programming. So there are so many algorithms, so many more. I'm just not listing them. I'm just listing the main things. Distance sorted, distance algorithm, and all those stuff. So there are so many algorithms that we cover after we cover the data structure things. So these are the basic two pillars. But there are few things which are common to both data structure and algorithm part, and that is one that which will be starting in the first. In the starting itself, we'll covering those. So one of that is time complexity thing. So it is a cross-cutting concern. So it will go through for every data structure that we read and every algorithm that we solve. We'll be figuring out what the time complexity is. So the first one will be the time complexity. The second one I feel is the recursion. Now recursion again, I have been talking to many students, right? So recursion is one of the most misunderstood concepts. You feel like you know recursion, but trust me, you would not have used recursion in that as depth as I'm expecting you to do it, because I have seen like most of the students, they know what recursion is, but when you ask the little nuances of recursion, that how it works internally and how you can use in the more complicated situation, they fail. So we'll be talking about recursion because this is a very important concept. I feel if you have a good hold on the recursion, the topics like dynamic programming, topic like tree, the topic like graph becomes very simple. Like 90% of the question in the tree can be solved with the recursion easily. And so is the case of the dynamic programming as well. So unless until you are not able to make a recursive function, trust me, you won't be able to solve a single problem in dynamic programming. So again, so recursion is the base of all the topics that we'll be studying in our all our coming sessions. So the recursion is something which I feel is very important concept. So we'll be understanding the recursion first as our building blocks for understanding DSN algorithm. And the another third most important thing that will be needed all through is sorting concepts. So again, sorting is something which will be used in the different data structures and in different algorithms for solving the problems. Said that, I don't think that anybody will ask you that, okay, you write me the sorting algorithm of bubble sort, or nobody will ask you to tell me how do we write, the merge sort or the quick sort. Nobody will ask you like that. But said that, the sorting concept will be used in the n number of questions, and also the logic how you do, quick sort or how you do merge sort. Those logics will be also applied in the multiple scenarios. So that is why sorting is something which is again common to all the data structures and algorithms that we'll be teaching in the future. So this is also will be covering in the start itself, so that wherever it is needed, we are ready to apply that. Right. So these three, first, second, and third, are like pre-read or our building block for understanding data structure algorithms. So we'll be taking these three in the starting of our lectures. Right. So these are the things, topics which we are going to cover. Now how the classes will go is that after every session I'll be giving you a list of the questions that I'll expect you to solve, and you have to solve those questions, come prepared in the next session, and we'll quickly spend like 15-20 minutes of time solving those questions. Like it will be kind of daily practice paper for you. And before, in the in the next session, every next session, the initial 15-20 minutes will be talking about the doubts that you had in the questions that have been given to you. So this is how we'll be try to follow the practice. Every session will be followed by a question which you will have to solve, and in every session, in the starting 15-20 minutes, we'll go through the doubts of all of you. We'll discuss the theory of each of the questions, and then we'll move on. So this is how we'll go. The another important thing is what is the language? I think most of you guys must be thinking that what is the language that we are going to use for this problem solving. See, to be fair to everyone, and to take a common, because we'll have to pick a common language. So for that scenes, I try to pick a language which is very common these days, which is used across the industry most widely. So Java is a language which is used in most, like 70% of the companies these days. So I'll be using Java as a common language to solve these kind of data structure problems in the session. But to those folks who don't know Java, I don't think that should be much of a problem, because most of the time I'll be only talking about the logic. See, data structure and algorithm is not about the language, but it's more about the logic. So I'll be mostly talking about the logic. So I don't think that will be an issue for you guys to understand the code, first thing. And when you're solving the problem, you're free to solve in any language. If you're comfortable solving in JavaScript, do it in JavaScript. If you're comfortable solving in Python, I'm totally fine. You can write in Python. If you want to solve in the C#, you can do in that language as well. Most of the language I'm already comfortable with. So even if you have to share your code, mostly I'll be able to help you out. Okay. So this is about the rules, the guidance, the flow, what I'm planning for this session is. But I'm more than open to add any new content in this, any additional thing that you want to add in this coursework. Please feel free to let me know. I'll just open 1 minute of window. Any doubts around this? Any questions? Any suggestions?
Hello, Vishwa.
Yeah, tell me.
Vishwa, what about searching concepts? We're not talking about searching anywhere over here.
So I'm not actually when I say the algorithms, the searching things will also get covered. So I'm not especially put each of the individual topics, but don't worry, everything that you can hear in the ecosystem of data structure and algorithm, everything will be covered.
Sure.
We'll be doing sorting, we'll be doing selection, we'll be also doing the searching. So that all will be covered as a part of the algorithm.
All right, fine. Cool.